In these problems, we are finding what is called a difference quotient. And lately, we've been talking about ways to find the slope at some instantaneous moment on a curve that keeps changing. So the slope is not the same. And in fact, it's changing everywhere. And we want to find the slope at some instant. We did that by trying to draw a tangent line, estimating that by drawing secant lines. And here's a secant line that would estimate the slope at B. If you started moving A closer and closer and closer to B, you get closer and closer to that slope of the tangent line. If we call this distance right here, if we call that H, there A is H apart from B on the X, then you get something like this. So point B represents the function at some number plus some distance H, and then uh, g of 5 represents that function at that number, and then divided by h. That's really the formula for the slope. If we look at this thing as h approaches 0, as a gets closer and closer to b, as h shrinks down to nothing, that limit is going to be the slope of that tangent line, which is going to be the derivative of the function. So this is a way to find this without graphing and just by using our algebra, hopefully. So let's see if we can make this work. I hope you'll take my word for it that this is written as the form of the slope. This is the difference in the y coordinates and the difference in the x coordinates that we defined as h here. Our function in this case is 3 times the square root of t, and we want to find g of 5 plus h and g of 5. So let's write that in here. G of 5 plus h. What that means is I'm going to put 5 plus h in for the t here. So that's going to be 3 times the square root of 5 plus h. And then g of 5 is just going to be, we're minusing that, it's just going to be 3 times the square root of 5. And that's all going to go over h. Now, to find the derivative of this function at 5, the slope of that tangent line, we actually need to take the limit of this as h approaches 0. We want this h to get infinitely close to 0. We can't do that right now just by evaluating this because we have h on the bottom. So we've got to do some algebra to figure that out. And let's see, I think what I'm going to do is just stick this 3 over here. And then we've got square root of 5 plus h minus 3 times the square root of 5. Nope, not the 3. I just removed the 3. Minus square root of 5 all over h. And I think what I'm going to do is actually multiply by the conjugate here, multiply the top and bottom by the conjugate of this thing. So we're going to say square root of 5 plus h plus square root of 5. So just changing the sign in between, because then I can use the difference of signs. We do have to multiply by the same thing on the bottom to keep this fraction the same. So 5 plus h plus square root of 5. And now let's do some simplifying here. So we've got 3, and then on the top, this comes down to this first term squared minus the second term squared. So that's going to just be 5 plus h and minus 5, and 5 and minus 5 are going to cancel out. So this is really just 3 times h, which is great news because we have an h in the bottom. Now we also still have on the bottom this thing we multiplied, the conjugate, so 5 plus h plus the square root of 5, and this h is going to cancel with this h, and now we actually have something that we can evaluate at 0. So we want to find, remember, the limit as h approaches 0 of this thing. So if we do that, if we put in a 0 for h here, that's going to go away. What we get on the bottom is just 2 square roots of 5. On the top, we've got a 3. We should rationalize the denominator here. So let's multiply the square root of 5 over square root of 5. That's going to give us 3 times the square root of 5 on top and 2 times 5 or 10 on the bottom. So that is actually the derivative of g at 5. And this thing right here, where is it? This thing, 3 over square root of 5 plus h plus square root of 5, that's the difference quotient. So that's what they'd want you to put in here. And then that actual number we calculated of the limit you put in here. Let's try one more of these to solidify it. So this time our function is 3t squared, and we're doing something a little different here. It's still a difference quotient. It's just written a little bit differently. We've got t minus 4 on the bottom, and we're gonna try to figure this out as t approaches 4. So the bottom of this is still going to go to 0, and we're still going to have to algebraically manipulate it so that it doesn't. But let's start plugging things in. Our function g of t is just 3t squared, so that's this part. And then g of 4, well, we can just calculate that. That's 3 times 4 squared, which is 16. Okay. And then we've got t minus 4 on the bottom. See what I'm going to do here. I'm going to factor out a 3 from the top, and we've got t squared minus 16. Difference of squares again. So 3 times, I can rewrite this as t plus 4 and t minus 4. That multiplies out to t squared minus 16. And now we can cancel that. So our difference quotient really simplifies to 3 times t plus 4. And figuring out the derivative of g of 4 is going to be pretty easy. We just put in 4. That's 4 plus 4 is 8 times 3, 24. So that is a little bit of work with finding a derivative at a given number using a difference quotient.